So, hello everyone. My name is Adonis, and I just wanted to share with you how we're using COMPAS RRC at Carleton University in Ottawa, Canada, within our lab CSALT and within these course that we offer to undergraduate and master's students in a pretty traditional architecture program. But first, just where I come from. I come from a pretty traditional architecture background, having done my bachelor's and master's in architectural design, both at Carleton University. And I work at a lab called CSALT, where there's two main focuses of the lab, materiality and fabrication, but focusing on the fabrication side for this talk. When I first started at the lab, in my fourth year of my undergrad, we had two pretty basic fabrication tools, a 3-axis CNC milling machine and a 3-axis ceramic 3D printer. But in between my master's and undergrad, we had two robots, two GoFas arrive, along with some support from ABB through some courses. And also at the same time, Philippe came for a 3-month sabbatical to basically teach us everything about COMPAS RRC. And after that summer, when Philippe left and the school year started, I started to continue learning and playing around with COMPAS RRC to see how it can fit within our workflows at Carleton. And part of that led to a project funded by a research funding organization called MyTax in Canada, where an industry partner is paired with an institution. And in my case, this industry project, or the industry partner was ABB Robotics Canada. And this project also doubled as my master's thesis, which was looking at how to integrate computational design and parametric design with robotic fabrication through COMPAS RRC to create, design, and fabricate adaptive retrofit installation panels for highly deformed existing buildings in the Canadian context. And this image here is just the half-scale prototype model that I built for that project. And along with that research as well was looking at scale and how code can scale and how robotic processes can scale. And what I did was a pretty simple assembly project with COMPAS RRC, testing things, developing a code to stack blocks of different heights in a closed loop design to fabrication process at Carleton in Ottawa with these two GoFas, and then visiting ETH here and with the help of Philippe, running the same process with two of the hanging robots here at the RFL as a proof of concept that the code can scale and that the processes can scale with some minor adjustments to match the different setups. And part of this was also how we can take this knowledge, share this knowledge to a broader range of people from different academic and professional backgrounds, running a workshop with Philippe and Cheryl, my professor, and as well Mike, at Rob Arch to really share this knowledge and bring it out into the world. Which leads me to what we offer at Carleton, which is an elective course for third-year undergraduates to master's thesis level. And it's an elective course that's around 13 weeks, 6 hours a week, in addition to their full course load of having studios and the tech courses and the history courses. So this is just an elective that the students choose, where the first 6 weeks, most of these students, or almost none of these students, have touched Grasshopper or any type of parametric design software, and absolutely none of them have any robotic fabrication experience. So the first 6 weeks is dedicated to introducing these students to these principles using COMPAS RRC as an easier entry point to robotic fabrication and robotic fabrication principles. And the last 7 weeks are dedicated to two projects where we keep it pretty open and broad, saying just draw and just build something with a robot and letting them figuring out the rest by themselves. But in addition to these two briefs, we just give them a blank kind of Grasshopper template and a Python template for COMPAS RRC and let them be as creative as they want, make it as complex as they want, and really just have fun learning how to use this tool to start thinking about robotic fabrication in the context of their design studios and their design processes. So for example, one of these students was looking at how to map sound, how to make map sound and map a song to a robotic toolpath with the GoFa to create a light painting, which is on the left. And then on the right was a pair of students. So these projects were done in pairs, using fire to draw on wood to map the flight path of a bumblebee, because that's what they just decided they wanted to do. right? And some other, like, although these are fun and pretty abstract projects, they are still learning real problems that you would face if you were to do these projects at a larger architectural scale. Like, for example, on the right, the group was looking at building a closed loop process to build this Tetris tower where they place a block, it senses what block it is and places it in the right direction or position. But in this project, they were learning about material tolerances, which they hadn't thought about before when they first started playing around with these tools, right? They thought the robot was a super precise tool, so they could basically do what comes out of the digital design. But they quickly learned that there's a lot more things to deal with within their process. And this slide is just some of the projects that came out of that course. So you can see there's a wide range of projects that come out. On the left are all the drawing assignments. On the right are the building assignments. And some of these line up with their studio courses. So they try to tie in their studio courses, their main kind of focus of the program, into this elective course. Some of them kind of just explore different things, but using COMPAS RRC to really just have fun, to learn how a robot works, what it's good for, what it's not good for, and how they can integrate it into their design processes. And what we have at the lab, so throughout the past 3 years, we had only the two small GOFAs, but we've recently had two more larger GOFAs come into the lab, and we just finished setting it up last month. So now we have four collaborative robots for more students to get their hands on these tools, to kind of bring this knowledge down into the undergraduate level as well, and have more students learn this, which is not really a common thing in Canadian architecture schools. But giving the students access to this allows kind of more learning and more fun to happen, and allowing these students to take these tools into their master's degree or whatever comes after into the industry when they work at an architecture firm and things like that. And I just want to end on this slide, which is just all the people that have been part of the lab since we started, and kind of a challenge that we face, and I think a lot of other labs face, which is the preservation of knowledge. Being a mainly primarily student lab, cohorts of students come and go, myself included being one of them. I'm leaving the lab at the end of the month, but looking at how do we keep this knowledge with the lab, but also continue to develop this knowledge as the cohorts of students kind of cycle through. And I think having these COMPAS RRC as a tool and other tools that lower the barrier of entry to tools like this and processes like this can help broaden the range of people and students that can learn this, and have basically help that transition between these cycles, make it a bit smoother. And that's it.